All right, happy snow day. Welcome to your math lesson. Hope you've got enough rest and you're ready to do this great assignment. I handed out the homework that goes with this lesson yesterday, so you should already have that. But for today's lesson, you're just going to need a blank sheet of paper, maybe your warm-up log if you want to do this warm-up on there like you normally would. So this is the warm-up that we would have had in class today. Pretty straightforward. If you want to give it a shot, hit pause on the video and jot down your answers to these. And when you're ready to see what the answers are, hit play, and I'll walk you through it. So give it a shot. Okay, so by now I'm hoping and assuming that you've already done these, and you're ready to check your answers. So for the first one, we've got x plus y times x minus y. So we've done these types of problems a million times this year. We're just using box. So I've got x plus y and x minus y. X. So this would be x squared. This would be a positive xy. This would be a negative xy. And this would be a negative y squared. So when I multiply this out, I end up with x squared. Positive xy minus xy, those are going to cancel. So these two are gone. And we've got a minus y squared. So that's the first answer. And that should be no surprise. That's difference of perfect squares. X plus y, x minus y. Okay, so the next one. Next one is a binomial times a trinomial. We've seen those before too. So this would just be x squared minus xy plus y squared and times x plus y. Okay, so when you multiply this out, that's going to give you x cubed. This is going to be a negative x squared y. This is going to be an xy squared. This is going to be an x squared y. And this is going to be a negative xy squared, and this will be a positive y to the third. So again, try to combine like terms. I have a negative x squared y and a positive x squared y, a positive xy squared and a negative xy squared. So all I'm left with is x cubed plus y cubed. And this is great midterm review because there's another formula you should know. You should have no surprise what this answer is because x squared plus y squared is the sum of cubes. That's when you had a binomial times a trinomial. Signs, remember, are plus minus plus if it started as a positive. And that's the formula that we've done. Okay, so last one. Last one's pretty similar, just some sign changes. So let's see if I can squeeze this in down here. I've got x minus y times x squared, xy, and y squared. So this is going to be x to the third. It's going to be an x squared y. This is going to be an xy squared. This is going to be a negative x squared y. This is going to be a negative xy squared. This would be a negative y to the third. So again, we want to combine like terms. X squared y, negative x squared y. Xy squared, negative xy squared. And the only thing I'm left with is x cubed minus y cubed. And again, should be no crazy surprise that that is the difference of cubes, and that's another way we factored. Okay, so we're going to use these in the notes in a second. So I'm going to switch over to a blank sheet of paper now and do the notes. It might help to have your calculator out too, so if you got your calculator, grab that. And you can label this Unit 8, Day 5. And this is called Polynomial Identities. Okay, sorry for the handwriting. It's not going to be as nice looking as usual. I'm writing with my finger on the laptop here. Okay, so I'm going to start out with recall. An identity is an expression that is always true, regardless of x value. Okay, so the warm-up were 3 identities that we already know. So here are ones we know. So the first identity that you all knew probably even before this year was that x squared minus y squared is always equal to x plus y times x minus y. So no matter what x and y are, those are always true. And this year we've done 2 more, and that's what you also saw in the warm-up. The sum of cubes, x cubed plus y cubed, is always the same as a binomial times a trinomial, plus minus plus. This is x plus y. This would be x squared, xy, and y squared. And that's a statement that's always true no matter what x and y is also. And the last one that we did in the warm-up, kind of the same idea, x cubed minus y cubed. We know that's minus plus plus, x and y, x squared minus xy, or plus xy plus y squared. So in the past we've looked at these as factoring exercises, but we also look at them as identities. They're an equation that's true no matter what x and y, what values x and y take. Okay, so the first type of question you're going to see on the homework is actually pretty straightforward. It's going to just say verify the following identity. And the identity that we're going to do is x plus a squared minus x minus a squared equals 4x, or 4ax, sorry. So these questions are kind of easy just because if it says verify the identity, that means they're supposed to be true. So this should be a true statement. Okay, so the one thing you got to remember when you're working identities is you can't cross the equal sign. So I'm always going to draw this kind of bar down here. And you can't, like normally when you have an equation, you might be able to like add 2 to both sides. You can't do that here. You got to work the left side separately from the right side and hope that you come up with the same number in the end. So in order to do the left side, first off, there's no work to do on the right side. The right side is going to be 4ax. So I'm hoping to get the left side to look like that also. So I have to do x plus a squared, which I need to use a box for. So x plus a times x plus a is x squared, ax, and a squared. So this would be x squared plus 2ax plus a squared. That's that first piece. Then I also need to multiply out the bottom piece, or the second piece. So that's x minus a squared, x minus a times x minus a. That's x squared minus ax plus a squared. So it's going to be minus, I'm going to put this in parentheses because of that minus, x squared. That'd be minus 2ax plus a squared. And remember when I'm subtracting, I got to change the signs. So I would want to make this plus, minus, just like we were doing with long division. Then I start combining like terms. I have positive x squared plus a negative x squared. Those are gone. I have the a squared plus a negative a squared. Those are gone. So I'm left with 2ax plus 2ax. That's 4ax. Once the two sides are equal, check. You've verified that it's an identity. So verifying just means doing the algebra and showing that both sides are equal. Okay, questions yet? Hopefully not. Okay, I'm going to turn the page, get a clean sheet, and do the next type. So here we go. Okay, for this next part, I want to say that some identities are helpful tools to doing mental math quickly. So some identities are helpful tools to doing mental math quickly. So, for example, use x squared minus y squared equals x minus y times x plus y. That's an identity that we know to evaluate. And first, I want to evaluate 50 squared minus 49 squared. Now, without using the identity, I have no idea what this is equal to. 50 squared, I can maybe figure that out in my head if I thought about it. 49 squared, that would take a lot. I'd have to maybe do some work off to the side. But look what happens if you use this identity. If you think of this as x and this as y, then it's just like x squared minus y squared. So this should equal x minus y, which would be 50 minus 49, times x plus y, which would be 50 plus 49. Now look at this. This is way easier to do in your head. 50 minus 49 is what? 1. And 50 plus 49 is 99. So 1 times 99 is what I ended up with, which is 99. So I did that pretty easily. Didn't need a calculator, but just to verify, 50 squared minus 49 squared is 99. Let's try another one. What if I asked you to multiply 51 times 49? This is kind of going the other way. So I don't have two things squared, I have two pieces multiplied. So it's like I'm looking at this. And how could I think of it like that? Well, I could think of it 51 as 50 plus 1. And I could think of 49 as 50 minus 1. So now that means, like 50 is x, 1 is y, 50 is x, 1 is y. So that should equal x squared minus y squared, which is what this identity says. So that would equal 50 squared minus 1 squared, which you should hopefully be able to do in your head. 50 squared, think 5 squared. 5 squared is 25. So if you do 50 times 50, you got 2 zeros. So it's 2,500 minus 1, because that's 1 squared. And you're left with 2499. And again, we could use the calculator to verify. 51 times 49. Def is 2499. So we're getting the same answers, but using these identities, we can do them in our head a little bit quicker. So that's not something you might use very often, but it's just a way that identities can be used. Okay, so I'm going to put both of what we've done so far together, kind of, in this next example. I want to say prove that a plus b squared is equal to a squared plus 2ab plus b squared. Then use it to calculate 35 squared. Okay, so for the first part of this, we're just verifying. So I'm just going to rewrite a plus b squared equals a squared plus 2ab plus b squared. And if I'm going to verify this, I got to draw that wall. I can't cross the wall, remember. And there's nothing I can do on the right-hand side, nothing to combine. For the left-hand side, I can multiply out. I can actually do what a plus b squared is. So I'm going to come over here and do. So a plus b is a squared, ab. This is also ab, and this is b squared. And when you add those together, you get a squared plus 2ab plus b squared. And what do you know? It's the same exact thing. Check. We just verified the identity. Okay, so that's easy. And that's honestly what the Regents is most likely to ask. Now they want to use that to calculate 35 squared. Okay, so 35 squared. Well, if I'm going to use this formula, I've got to think of it as something like a plus b. So I got to take any two numbers that add to 35. Keeping in mind that I'm going to want to do what a squared is and b squared is in my formula. So two numbers that add to 35 that are kind of easy are 30 plus 5. So do you all agree that 35 squared is the same as 30 plus 5 squared? Of course you do. Okay, so now this is a and this is b. So that's going to equal a squared, which is 30 squared, plus 2ab. A is 30, b is 5, plus b squared, 5 squared. And my hope is that I might be able to multiply this in my head. And 30 squared, 3 squared is 9. 30 times 30 would have 2 zeros, so 900. Plus, I would do 2 times 5 is 10, and 10 times 30 is 300. And 5 squared is 25. So it looks like we've got 900 plus 300, which is 1200, plus 25, 1225. So that's not the only way to answer that question, but that's one option. Okay. So the last thing we have to talk about today are Pythagorean triples. So when we're ready to go on, if you're still writing, pause the video for a second, but otherwise, here we go. So definition of a Pythagorean triple. A Pythagorean triple are three integers. Integers are going to be important later on, so remember that. Three integers, a, b, and c, that can form the sides of a right triangle. Okay, so here's some examples of Pythagorean triples. Probably the most famous one. Can you think of any off the top of your head? First one you should think of is the old 3, 4, 5. And that definitely satisfies the Pythagorean theorem. Maybe I should say, what is the Pythagorean theorem? Hopefully you're all screaming, a squared plus b squared equals c squared. So that satisfies the Pythagorean theorem because 3 squared plus 4 squared equals 5 squared. Remember, c always has to be the hypotenuse. So 9 plus 16, def equals 25. Check. Another Pythagorean triple. Maybe you've heard of 7, 24, 25. You did a lot of these with geometry last year. Sorry, you geometry haters. I feel for you. Is that a Pythagorean triple? Well, 7 squared plus 24 squared. Does that equal 25 squared? This one I might have to check out. So 7 squared plus 24 squared. What's that equal to? 625. And I believe that is 25 squared. Yup. So those three are also Pythagorean triples. Check. And what about 1, 4, 5? Is that a Pythagorean triple? Well, if it is, it would have to satisfy 1 squared plus 4 squared equals 5 squared. But 1 plus 16 is 17, def not equal to 25. So that one gets a big no, not a Pythagorean triple. So not all sets of 3 numbers are Pythagorean triples. It's only the right combinations. But there are a bunch of them. There's actually infinitely many. Okay, so how is this related to identities? I'm going to show you. Given the following right triangle, I'm going to put 2x here, x squared plus 1 here, and x squared minus 1 here. So given that right triangle, for part A, I want you to show, basically show the Pythagorean theorem holds. So show that 2x squared plus x squared minus 1 squared really does equal x squared plus 1 squared. So that's just thinking of this as A, this is B, and this is C. So if those really can be lengths in a right triangle, then that would have to be true. Okay, so let's go ahead and show this. What is 2x squared? Hopefully you're saying 4x squared, because that 2 has to go to both pieces. So that's 4x squared plus x squared minus 1 squared. Okay, maybe I need to come down here and do that. So x squared minus 1 times x squared minus 1 would be x to the 4th minus x squared plus 1. So this is x to the 4th minus 2x squared plus 1. I should probably draw my wall down here. And we can clean things up a little bit. We've got a 4x squared and a negative 2x squared. So this becomes x to the 4th plus 2x squared plus 1. So I'm going to hope that other side comes out to be the same thing. And if it does, we've shown it. Okay, so I need to come over here and do x squared plus 1 squared. So that's x to the 4th plus x squared plus 1. So that would be x to the 4th plus 2x squared plus 1. What do you know? It's an identity. That's good news. Okay, part B. If x equals 3, what Pythagorean triple would this produce? Okay, so this isn't all that hard either. So if x is 3, this side would be 2 times 3. This side would be 3 squared plus 1. And this side would be 3 squared minus 1. So that would make the Pythagorean triple 6. 9 plus 1 is 10. And 9 minus 1 is 8. So I would say my answer is 6, 8, 10. And you could do that with any integer, any x value, well, that would give you positive values. So like x equals 1 would give us a problem because this side would be 0. But I can do that with almost any x value, and I can get 3 integers that are Pythagorean triples. Now if I wanted you to verify that, you could always do 6 squared plus 8 squared equals 10 squared. Make sure they actually are. So that's 36 plus 64, 100. Yup, that's 10 squared. So you're done. That's it. Okay, last question. And this is similar to the last question on your homework, which is a little tricky. So if you have trouble on that last question on the homework, go back and rewatch this part. Okay, here we go. Another polynomial identity. For short, I'm just going to say another poly ID that generates Pythagorean triples is x squared minus y squared, 2xy, and x squared plus y squared. I think on the homework they ask you to verify that. So you'll have to do a squared plus b squared equals c squared with those values and show that it's true, like we did in the last one. But for this question, I want to know what values of x and y will generate the triple 9, 40, 41. Okay, so 9, 40, 41 is a valid Pythagorean triple. If you do 9 squared plus 40 squared, you'll get 41 squared. So it works. So if I want to verify, or I want to find out what values of x and y will make these, it's kind of like going backwards from the last one. So 9, 40, and 41, which one of those has to be the hypotenuse? This one. This one is definitely C. So x squared plus y squared definitely has to equal 41. And maybe you could guess and check and figure out x and y, but let's do some math instead. So 9 and 40. These are either A or B. I don't really know which one's which. So the annoying thing is I have to kind of just guess here and see if it works out. So let's give this a shot. I know x squared plus y squared equals 41. Let's just say 2xy is 9 and x squared minus y squared is 40. Maybe that'll work. Okay, so how could I solve this? Well, you've seen 3 equations, 3 unknowns. Here there's only 2 unknowns, but same idea. We can use the elimination method. Do you see 2 equations here that if you add them together, one of the variables will cancel out real nice? How about these 2? If I take x squared plus y squared equals 41, and x squared minus y squared equals 40, if I add those together, what do we get? Well, the y squareds are gone. I'd have 2x squared equals 81. I'd have to divide by 2. So we'd get x squared equals 40.5. If I take the square root, I'm definitely not going to get an integer. And that matters. Remember, Pythagorean triples are 3 integers. I underlined that when we did the definition that make the equation true. So this isn't right. So what could possibly have gone wrong? Well, remember what I said. 9 and 40 are either A and B. We kind of have to just guess, and we guessed wrong. So 41 has to be the hypotenuse, so this one's locked in. But I could make this 40 and this 9. See if that gives us an integer. Okay, so now I'm going to do the same thing. I'm going to take x squared plus y squared equals 41. And this time x squared minus y squared equals 9. Maybe this will give us better luck. So I get 2x squared equals 50. Divide by 2, divide by 2. X squared equals 25. It's looking good. Square root. X is 5. So that is a value of x I can use because it's an integer. And let's figure out what y would be then. I could use any of these equations. Let's just use 2xy. So 2xy we said is 40. So 2 times 5 times y is 40, which means 10y equals 40, and y is 4. So if x is 5 and y is 4, that will generate the triple 40, or 9, 40, 41. And you can check really quickly just by plugging them in. 2 times 5 times 4 is 40. There's that number. 5 squared minus 4 squared, 25 minus 16, there's your 9. And 5 squared plus 4 squared, 25 plus 16, there's your 41. So you got your answers. Okay, so that's the end of the lesson. to make your snow day all the more enjoyable, you have so much math you can be doing. There's the homework I gave yesterday on the long division. There's the homework I gave you on this stuff. So there's those two homeworks are both due on Monday, so make sure those get done. And then if you still just are so bored and want to do more math, you've got the optional green sheet to do. You've got the midterm review packet that's due next Friday to do. And isn't it lucky you've got a 3-day weekend to work on that now? Yes. And if for some crazy, terrible, irresponsible reason you left it at school, you can print off a copy off my website, which I also emailed you a link to. So plenty to keep you busy. Have a great day. Feel free to send me an email if you got any questions, and I will see you all on Monday.